Here's a quick review of dimensional analysis between moles and mass in grams. So first we're asked to figure out the mass of 1 mole of carbon. We don't actually have to do any calculations for this one. We just look at the periodic table, and it tells us that the mass of 1 mole of carbon is 12.011 grams. That's the mass according to the periodic table for carbon. The mass of 2 moles of carbon, well, I can just take that 1 mole of carbon mass and multiply it by 2. 2 times 12.011 grams is going to give us 24.022 grams. That would be the mass of 2 moles of carbon. I'm going to go ahead and do this again using the railroad tracks, just so we can kind of get an idea of how those railroad tracks work when we're converting between moles and mass. So I'm going to start with my given. My given is 2 moles of carbon. I'm going to convert moles to grams. Since I have moles here on top, I'm going to put mole on the bottom. I'm going to convert my moles to grams, put grams on the top. I know that the periodic table tells us that there's 12.011 grams in 1 mole of carbon. I've set it up this way so that moles on top and moles on bottom can cancel out. All we're left with is grams, which is good because the question is asking us for mass. So now with my calculator, I'm going to do multiplying across the top, divided by everything on the bottom. Multiply across the top, divide by everything on the bottom. So 2 times 12.011 divided by 1 is going to give us 24.022 grams, which is exactly what we knew the answer should be. This one we're going to do similarly. I have 6 grams of carbon. This is my given. So that's what I'm going to start with in my railroad tracks, 6 grams of carbon. I want to convert my grams to moles. I need to get rid of grams. Grams is on the top right now. I'm going to put it on the bottom. Convert my grams to moles, put moles on the top. The periodic table tells me that there are 12.011 grams in 1 mole of carbon. 12.011 grams in 1 mole of carbon. We set it up this way so that grams on top and grams on bottom cancel out. We're left with moles. That's good because that's what my question is asking for. So now I'm going to multiply across the top. 6 times 1 divided by 12.011. 6 times 1 divided by 12.011 is going to give us 0.49954, lots and lots of decimal places. Since I have 2 sig figs here in my given, I'm going to keep 2 sig figs in my final answer. This 9 is going to turn that 9 into a 0, which is going to turn that 4 into a 5. So our final answer is just about 0.50 moles of carbon. You're probably thinking, why didn't you sig fig check this one? When 2 is written as a number, it's hard to tell exactly how many sig figs there are, so I didn't check sig figs. All right, let's do some more practice problems. Go ahead and pause the video. Do these 3 on your own. Restart the video to check your work. All right, hopefully you have some answers on a piece of paper. Let's go ahead and do these problems together. So this is our given 2.4 moles of gold. 2.4 moles of gold. Gold is AU on the periodic table. Since I have moles here in the given, I'm going to put moles on the bottom to get moles to cancel out. Convert my moles to grams, since that's what the question is asking us to find. Looking at the periodic table, I see that the mass of gold is 196.967 grams per 1 mole. My moles on top and my moles on bottom cancel out. Now I'm going to multiply by everything on the top, divide by everything on the bottom. 2.4 times 196.967 divided by 1 is going to give us 472. 472 point lots of decimal places. Since I have 2 sig figs here, I'm going to keep 2 sig figs here. That 2 is going to leave that 7 a 7, and so we have just about 470 grams of gold. How many grams is 1.5 moles of sodium chloride? 1.5 moles of sodium chloride. So this one's a little bit trickier because I have a compound, not an element. So I do need to find the molar mass of a compound. Sodium chloride's formula is NaCl. So I'm going to add my 22.990 for sodium's mass and 35.453 for chlorine's mass, and that's going to give us 22.990 plus 35.453, 58.443 grams per mole is the molar mass of sodium chloride. So I'm going to take my given here, 1.5 moles of sodium chloride. To convert to grams, I'm going to put moles on the bottom so that my moles on top and my moles on bottom cancel out. Convert those moles to grams. We just figured out that there are 58.443 grams in each mole of sodium chloride. So now my moles on top and my moles on bottom cancel out. When we do our math, we're going to multiply across the top, divide by everything on the bottom. 1.5 times 58.443 divided by 1. 1.5 times 58.443 divided by 1 is going to give us 87.6645. I have 2 sig figs here in my given, so I'm going to keep 2 sig figs. That 6 is going to turn that 7 into an 8. And so our answer is just about 88 grams of sodium chloride. One more, 12 grams of helium gas. Helium is a noble gas, and so the formula is going to be just He, it's not diatomic. If I have 12 grams of helium and I want to convert that to moles, I can put my grams on the bottom and convert to moles on the top. The periodic table tells me that the molar mass of helium is 4.003 grams per each 1 mole. So now I can cancel out grams on top and bottom. I'm going to multiply across the top, divide by everything on the bottom. That's going to give us 12 times 1 divided by 4.003, 2.99775, lots of decimal places. I have 2 sig figs. I'm going to keep 1 2. That 9 is going to turn that 9 into a 0, which turns that 2 into a 3. And so 2 sig figs is going to be just about 3.0 moles of helium.